Okay, we're going to switch gears a little bit, and this is a different way to calculate delta H. So there's a bunch of different ways, depending on the data that I give you, that you can calculate the enthalpy of a reaction. So the new way, another way, depending on what I give you, is called Hess's law. And what Hess's law says is that a reaction can be written as a series of steps, first of all. And that is true for almost all chemical reactions. It's hardly ever just one thing reacting with another thing. There's usually like a lot of little reactions that have to happen to get to your product. We just usually write the overall equation. And the many steps kind of for that reaction is actually what's called a mechanism. So we're going to be looking at what are called mechanisms. And if you have the delta H for each step in the process, then if you add up all of those delta H's, you will get the delta H for the overall reaction. Okay, so we use this a lot when you can't directly measure the change in enthalpy because maybe there's issues with the reaction, there's too many different steps. Sometimes it's just very difficult to measure that energy change. You can't contain it, it's going to explode, all kinds of stuff like that. So what we do is we measure the specific steps, their enthalpies, and then add them together. So this is how these reactions or these questions are going to look. It'll be like, okay, the overall reaction for something is this. Two carbon graphites react with an O2 molecule gas to make two carbon monoxides. I want to know what the delta H of this reaction is. Well, I can't really do this very well in a bomb calorimeter, or maybe I don't have a bomb calorimeter. I can, however, measure the enthalpy change when carbon reacts with oxygen to make CO2. And I know that that value is negative 393.5 kilojoules. And I know that the two carbon monoxides reacting with oxygen makes 2 CO2 and the enthalpy change for that reaction. Now, how do these help me get to the enthalpy of my overall reaction? Well, this is the process kind of that you're going to take. I give you the steps and we want to make it the overall reaction. So what you have to do is we want to get these reactions to add together to equal my overall reaction. And we can do that by manipulating these equations. So what I want you to do is check molecule by molecule in the overall reaction. What I mean by that is in my overall reaction up here, I want to look at carbon graphite. I want to look at oxygen gas, and I want to look at CO, each individually, okay? And you want to find them in the steps. So for example, if I'm talking about carbon graphite, the only place that exists in my steps is right here. Okay, so first I'm going to focus on this reaction and be like, okay, is it on the correct side? Meaning, is it react? Well, in my overall reaction, it is a reactant. In this step, it is also a reactant, so I'm good. If it wasn't, I'd have to flip that reaction. Does it have the correct coefficient? Well, if I'm looking at graphite, in the overall reaction, it should have a coefficient of 2. In this reaction, it only has a coefficient of 1. So what I'm going to need to do is double this whole reaction. If I double the reaction, it doubles the delta H. So you'll see I wrote this down here. Okay, so I rewrote that equation. 2C plus 2O2 makes 2 CO2, and the delta H for that reaction is whatever 2 times negative 393.5 kilojoules is. Okay, so I checked the side and the coefficient. We're going to do that for all of these, okay? So you're checking that, and then you're going to flip, or you're going to multiply reactions and their delta H's, and then check that your equation works out. That's my step 2.5, and then add up all the delta H's. So I just did the first one. Now I want to check oxygen. Okay, so O2 is actually in both equations. So what I'm going to do is I'm going to skip that one. If it's in multiple equations, skip that one. It'll probably work out in the end. If not, you can go back and look at it. Now I'm going to look at carbon monoxide. Okay, carbon monoxide is only right here. So first, is it on the right side? No, it's supposed to be a product, and over here it's a reactant. So what I have to do is I have to flip this equation, okay, which means I just flip the sign of delta H. So that one's going to be positive. So I will rewrite it down here. I wrote it as 2 CO2 makes 2 CO plus an O2, and the delta H of that is positive 556.0 kilojoules. Now, why did I do this? Why did I double this and then flip this? How does that get me to my overall equation? So once I do that, what you want to do is see, okay, I'm going to smush these equations together. So technically, this is a reactant, and this is a reactant. Whereas this is a product, this is a product, and this is a product. But if something exists on both sides of the reactions, you need to cancel it out. For example, I have 2 CO2s on the product side of this reaction and 2 CO2s on the reactant side of this reaction. Those cancel out. Okay, I have oxygen, 2 oxygens on the left side up here, 1 oxygen on the right side down here. So one of the oxygens cancels out, the other one is still there. So what am I left with? I am left with 2 carbon graphites plus 1 oxygen makes 2 CO. So I got 2 COs down here. Notice this equation now, once I've smushed everything together, actually gives me my overall reaction that I was looking for. That's like my double check. So if this is correct, then that means I can just add these values together. So 2 times negative 393.5 plus 566.0 gives me negative 221 kilojoules. So this is the answer for this equation. So the whole goal of this is manipulating the steps to get them to add up, cancel out, and then you add up those delta H's, and that gives you the delta H for that reaction. That is called Hess's law. Okay, so I am going to do one with you, and then I will walk through. Oh, I've only got one example here, so I'm going to do this one with you. All right, so find delta H for this reaction. This is my overall reaction. That's what I want everything to add up to, given the following 3 reactions. So that means these are the stepwise reactions, and I need to get them to add up to this. So as I said before, I'm going to go molecule by molecule for my overall reaction. So I'd be like, okay, tungsten solid. So I would find that in my reactions. The only place it exists is in this first reaction here. Is it on the correct side? Yes, it's a reactant here. It is also a reactant here. Does it have the correct coefficient? No. It should be a 1, but here it is a 2. So I'm actually going to half this whole thing. So I left this space. You could do it like right underneath. So I'm going to half this. So 2 over 2 is now just 1 tungsten plus 3/2 of O2 gas makes 1 WO3 solid. Whatever I did the equation, I also have to do over here. So it's a half of whatever negative 1680.6 kilojoules is. Okay, so now I did that. I can ignore that equation. All right, I rewrote it the way that I needed it. All right, same thing now, C graphite. C graphite only exists in the second equation. Is it on the correct side? Yes, it's a reactant. Does it have the correct coefficient? Yes, it should just be a 1. So I'm not going to touch this reaction. I'm leaving it. Right? Last, WC solid. Let's see, that only exists here. It should be a product, and it should have a 1 as the coefficient. So I have to flip this one and divide it by 2. So I'm going to do both things at the same time. I'm flipping it and dividing it by 2. So now my products are my reactions are my products. So now it's just 1 WO3 solid plus 1 CO2 gas makes 1 WC solid and 5/2 O2 gas. So I flipped it, passing that out, and I halved it. So my delta H is now going to be 1/2 of positive 2391.6 kilojoules. I flipped and halved it. Now that's gone. So now these are my 3 reactions. Oops, 2, 3 that I'm going to add together and make sure that it matches my overall equation. This is my like double check. So anything that exists on both sides, you want to cancel out. Okay, so I have a WO3 solid here, WO3 solid here. Those are going to go away. The only other thing, oh, wait, nope, I've got some oxygens, carbon stays there. Oh, CO2. There's a CO2 here and a CO2 here. Those are going to cancel out. All right, I also have oxygen. So notice on the left, I have 1 oxygen here and 3/2 here. So that's like 2.5. And down here, I have 5/2 over here, which is 2.5. So actually, all of these oxygens, left side and right side, are going to cancel out. And all I am left with is this, and this. So the reaction is W solid plus C graphite makes WC solid. Is that my overall reaction? Yes, it matches this. Great. That means I can add this value, and this value together to get the delta H of this reaction. So it should be negative 38 kilojoules. Now I recommend trying this in your calculator because if you don't get negative 38, you did some order of operations wrong. So double check it and make sure you can do this.